This is the 2014-15 math class, grade 10, and here's Mr. Boudreau. Da-da-da-da.
Thank you for that wonderful introduction, Martin. Okay, today we're going to be looking at solving systems of equations. All right, so solving systems, and you already know one way to do that. So we're going to start with that. So last year you learned a method called the comparison method. So method 1 is going to be comparison method. Alright, so the comparison method. You use this method when you have two equations, and those two equations are both in the form y equals ax plus b. So you have two equations. Equation 1 is y equals ax plus b. Equation 2 is y equals ax plus b. And when you solve the by comparison method, what you're doing is you're taking the two equations and you're going to set them equal to each other. Okay? So, like I said, this is review from last year. And we can do an example. I'll do one of the examples that's in your book that you asked me about. I'm going to do the first one. I'm going to do 2a first on page 41. So they have y equals, so example, y equals negative x plus 10, and you have y equals x minus 4. Okay, so those are your two equations. When I say set them equal to each other, what I mean is you're going to take your back half of your equations, so the negative x plus 10 and the x minus 4, and you're going to put those equal to each other. So basically you're setting y equal to y. So we'll do that over here. So negative x plus 10 equals x minus 4. Does this look more familiar now, Marty?
Yeah.
What I'm doing here?
Quite
Okay,
a bit.
perfect.
Not too much.
So do you have a guess at what my first step is going to be to solve this then?
Negative y. Subtract the x.
Subtract the x from both sides. So if I'm subtracting x, I've got positive x here, and I'm going to want to move it this way. So if I want to do that, I'm going to subtract x from both sides. So I'm going to go minus x and minus x. Here I have x minus x, so those cancel out. And I'm going to have x, negative x minus another x is negative 2x plus 10 equals negative 4. So now I have all my x's over on my left-hand side. That means I got to move all my numbers over to the right-hand side. So how am I going to move that positive 10 over to the right-hand side? Subtract it. Perfect. So I'm going to subtract 10 from both sides. So 10 minus 10, gone. Let me get rid of that little mark I made.
Shouldn't the bottom one be ax minus b? Like it's a comparison method. Y equals ax plus b, and bottom one y equals ax minus b.
No, they're both in like, the general form for that, or the way we write that down is y equals ax plus b no matter what. Your b could be negative. In this case, the second one is negative. But they could equally both be positive, or they could both be negative. It wouldn't make a difference. It just means that you have a negative y-intercept or a positive y-intercept. In this case, you have one that's positive, the positive 10, and one that's negative, the negative 4. Okay. So now I'm left with negative 2x equals negative 4 minus 10 is with negative 14. And then what am I going to do to get my x by itself?
Divided by 2, negative 2.
Divide by negative 2. Perfect. Divided by negative 2, divided by negative 2. Negative 2's cancel out. I've got x equals positive 7. I'll make that a little smaller. Okay, because I'm not done yet. I've found x, but that's only half the answer. What's the other half of the answer? Finding y. And how will I find y?
By plugging in x.
Into? Which one? Top one or bottom one? Doesn't matter. Which one do you want to use, Sean?
Bottom one.
So then I'm going to sub x into, call it x, quote, into one of the rules. Alright, so I'll use the, which one did you say, Sean? Bottom one?
Yeah.
So I'm going to go y equals x minus 4 and sub in my x. So y equals 7 minus 4, y equals 3. And just to show, it doesn't matter whether I put it into the top one or the bottom one, we'll just check it with the other one. Okay, so it would be y equals negative x plus 10. So if I plugged it in, it would be y equals negative x, so negative of 7 is negative 7 plus 10. And you see you get y equals 3 again. So your solution for this method, the system of equations, remember we talked about this earlier on, the solution is at what point do these two lines have exactly the same coordinates? There's only one point, and that point for this one is the point 7, 3. Okay, so that's your final answer right there. Right. So that's the first and only way that you guys know how to solve systems of equations.
Is there another way?
There's two other ways.
Let's find out.
Let's find them out, Marty. So this way was the one where if you have both equations and y equals ax plus b. A few classes ago you learned about the general form of an equation, the ax plus by plus c equals 0. So that's the other way you could be given an equation, and that's the other way that you could have to solve a system of equations if it included one that was given to you in that method. So let's look at another one. All right, any questions here? We all right? Okay, cool. Move this out of the way. So method 2. Okay, so that first method was called comparison method. This is going to be called substitution method. Okay, so substitution method. Substitution method is going to be useful to you if you have one equation in y equals ax plus b. Alright, and the other equation is in general form, so ax plus by plus c equals 0. And actually, it doesn't matter if it equals 0 or if they have a number over there. The key is, so the key for substitution method is that you have in one of your equations a variable all alone. So in this case, my y here is all alone on one side of one of the equations. And in the other equation, or in the other rule, you have your x and your y on the same side of the equation. So that's kind of the key you're looking for if you're going to use substitution method. One variable all by itself on one side of the equal sign. In the other rule, your x and your y are on the same side of the equation. This c could be here, or there could be a number over here. It doesn't make a difference in that regard. Okay, so in this case, y is by itself, and we have the general form. All right. So let's look at an example of what that looks like and how substitution method works. This is new, so I'll go through it a little bit slower. So example, let's do this one. 3x plus 2y equals 5. So you can see it doesn't have 0, but that's okay. As long as your x and your y are on the same side of the equation, that's what we're looking for. And then the other one is y equals negative x minus 4. Okay. So this is called the substitution method for a reason. It's because you're going to substitute something into one of your equations. Okay. So step 1 for this, write it over here in red. So step 1 is going to be to sub y your second equation. Now that kind of sounds a little bit confusing. What does that mean to sub y into your other equation? All right. Here we have y. The equation is telling you that y is equal to negative x minus 4. What we're going to do is we're going to take this y, which is equal to negative x minus 4, and sub it into this equation on top here. So you're always subbing from the one that has the isolated variable, the variable all by itself, into the other equation. All right. So that's what this. Here's what this looks like. We're going to take the equation. I'll put a 1 here to mirror that. So step 1, we're going to take 3x plus 2y equals 5, and we're going to sub this into it. Okay. So instead of writing y, so 3x stays the same. Instead of writing y, I'm going to write negative x minus 4. And it's still equal to 5. So I'm going to stop there. I want you to look at what I did and make sure you understand why I did it. Okay. I took what they told. I'm going to get rid of this line because I find it kind of a little bit distracting. Erase. It's not going to erase for me. Alright, fine. I took this, what they told me y was equal to, and I wrote it instead of the y that's right here. Okay. So instead of writing y, I wrote negative x minus 4, because they told me that y was equal to negative x minus 4. Is that alright?
Yeah.
See that? You're okay with that? You're comfortable with that? Now this is something that we can solve using algebra. Like I told you before, algebra never goes away. Alright? We just have an equation that has x's in it, so we can solve for x. So 3x, okay. I have positive 2, I'm going to multiply by my negative x, which is going to give me what? Positive 2 times negative x
Negative 2x.
is going to give me a negative 2x. Positive 2 times negative 4, negative 8, equals 5. I have two things I can put together here. I've got my 3x and my 2x. So 3x minus 2x is going to give me what? X, just plain old x. So I've got x minus 8 equals 5. What am I going to do to get my x by itself?
What is x? Add the 8 on both sides. That.
Plus 8. Plus 8. I'm not going to minus 8 because, or minus x, because x is already by itself on one side. If I had x's on both sides, then I would have to do that step, but I don't have to here. So 8, negative 8 plus 8 is gone.
13.
X equals 13. Am I done?
Nope.
Why not?
Where's the y?
Perfect. So I guess I should put in a step 2 in red here so I can keep track. You sub your y in, and then you, step 2, solve for x. And then step 3, plug x into one of the equations and solve for y. Now, does it matter which equation I choose? No, just like before, it doesn't matter which equation I choose. But there's one that I always choose. Can you guess which one I always choose?
X. General y equals x.
Right, the functional form one, the y equals ax plus b one. Why would I choose that one? Why would you think that would be a natural choice?
Simplest one.
It's actually the second one on this list. I'm solving for y, and y is already alone. So I go back to my y equals negative x minus 4, because y is already isolated. I don't have to do as much work. I'm lazy. You could do it in the other one, it would work. But I'm going to sub in my negative, so my positive 13, so negative of x is negative 13 minus 4, and I get y equals negative 17. And so my solution by substitution method here is the point 13, negative 17. You could have subbed it into this first equation here and solved for y, and you would have got the exact same answer. You have to. It's the way it works. But I think this one is easier. So this was step. So step 1, if I label it, step 1 is here. Step 2 is, oops, pen. Step 2 is here, and step 3 is here. So if I mirror my 1, 2, 3. Okay. So you consider substitution method just to be another tool that's in your toolbox. You had the comparison method and it was the only one you had before. Now you could use either comparison method or substitution method, and you could get yourself to the right answer. Does everybody have all of this copied down? So I can go to a fresh screen. Okay. Third method is the most interesting method, in my opinion. So third method okay, this is called either, same thing, you'll hear me call it both, the addition method or elimination. Elimination sounds a little bit more intense. So it's either the addition method or the elimination method. Okay. So far we found a method that we use when we have them both in y equals ax plus b. Right? We've got a method that we use when we have one that's in y equals ax plus b and the other one is in general form. Can you guess what this one's going to be for?
Both in general.
When they're both in general form. Perfect. So we use this. Equation 1 is ax plus by plus c equals 0. And when equation 2 is also ax plus by plus c equals 0. Okay. So here's an example of how this looks. And I'll walk you through with steps the same way I did before. There's a few more steps in this one than there are in the other two. So example. We have 3x plus 7y equals 8. And we have negative 3x. We have negative 4x plus y equals negative 6.
So those are two examples?
So this is the example. These are your two equations we're going to find the solution for. So we have these two equations and they're great. They look good. Okay. Here's what we're going to do. We're going to label them equation 1 and equation 2. So we're going to call this
So what happened to B?
equation 1 and this equation 2. What was that, Marty?
What happened to the B?
The b. Which b?
Negative 4x plus y.
So what's my b if there's nothing written there?
Y.
That's a y. Is that
Yeah, it is y.
it's a y? So my b is 1. If there's no b, if there's no number written in front of it, you assume that 1 is there.
Okay.
Alright? So, step 1, and these steps are going to sound kind of silly, but you'll see why we do them in a second. Okay? So step 1. multiply equation 1, so the first equation, by the coefficient. What's the coefficient? If I say, what is the coefficient of x in equation 2? What is the coefficient of x?
No idea.
Anybody? Your coefficient is the number that's attached to your x. Okay. So in this case, the coefficient of x in equation 2 is -4. Okay. So we're going to multiply equation 1. So I'm going to take my equation 1, this whole thing, and I'm going to multiply that, the whole thing,
By equation 2.
by -4. So it's a little confusing because of the times here. I'm going to make that the old dot. That also means multiply.
What's the dot mean?
So a dot means multiplication. So taking all of equation number 1 and I'm multiplying it by -4.
I remember.
Okay. So down here I'm going to write step 1 so that I can show that this is what I've done. And let's do this. So -4 times -3 equals what?
12.
Positive 12. So I have 12x. -4 times positive 7. So -28y. -4 times positive 8.
Well, -34.
-32. So I have 12x minus 28y equals -32. Okay. Step 2, multiply equation 2 by the, there's going to be a keyword added in here, negative of the coefficient So multiply equation 2 by the negative of the coefficient of x in equation 1. Coefficient of x in equation 1 for this one is -3. What is the negative of -3? Positive 3. So we're going to multiply the whole thing by 3. What is 3 times -4? -12. So we got -12x. 3 times y? 3y. So plus 3y equals, what's 3 times -6? -18. You'll notice something. And this is the perfect check to see if you've done step 1 and step 2 right. Okay. If you've done step 1 and step 2 right, your x's will have the exact same coefficients, and one will be positive and the other will be negative. And here's where the addition or the elimination word comes from, step 3. Step 3 is going to be add the two equations. I'm going to add these two equations. What is 12 plus -12? 0. positive plus its negative, they cancel out. The reason that we did step 1 and 2 was so that these two things would cancel out. If you do step 1 and step 2 right, they will always cancel out. Now I have negative 28 plus 3, negative 25y, equals negative 32 plus negative 18 is negative 50. Okay. Are we all right with what I did here? I took my 12x plus my negative 12x is gone, cancels out, 0x. Negative 28y plus 3y is negative 25y. Negative 32 plus negative 18 is negative 50. And now we're left with, so that was step 3. Step 4, solve for y. If you do step 1 and 2 exactly as I said, x will always cancel out, you'll always be left with y. I'm going to divide both sides by negative 25. Left with y equals 2. And in this case, so that is step 4. And in this case, the 5th step, again, if you do 1 and 2 exactly like I said, you've got to solve for x. That's what you're left to do. So I will just shrink this a little bit and give me some room to do that. Okay, so step 5 is solve for x. You're going to plug it into one of your two equations that you started with. So I'm going to start with my negative 3x plus 7y equals 8.
Yes.
And actually, you could go back to this equation here, or if your little heart desired, you could actually use either of these two equations as well, your ones you modified, and it would work. Okay? But you have to choose one of them. You can't mix them all together.
No.
Mixing them all together would not work.
I know, it's just insane.
So, let's plug in our y. We already solved for y. So negative 3x plus 7 times 2 equals 8. Negative 3x plus 14 equals 8. I'm going to subtract 14 from both sides. That would get rid of that. So I got negative 3x equals, what's 8 minus 14?
Negative 9?
No, negative 6.
Yeah.
Okay, and then I'm going to divide both sides by negative 3. And that'll give me x equals 2. So in this case, our solution for our equation was actually x is equal to 2 and y is equal to 2. Okay, that is your third method. So you have 3 new methods to solve for equations. You have comparison method, where both equations are in functional form. They're both in y equals ax plus b. You have substitution method, where one of them is in y equals ax plus b, and the other one is in general form. And then the last one, addition or the elimination method, where both equations are in general form. Are there any questions about any of this?